Hi everyone, thanks for coming to the channel. If this is your first time, my name is Peter. If you've been to the channel before, thank you for coming back. Just a brief background if you're new to the channel. I spent my working career in the maritime industry, with the last 20 as a trainer and assessor. I'm retired now, so I spend my time making short videos on marine topics and tutoring. I'm also an invigilator with the Office of Maritime Communications, so to fund the videos, I conduct marine radio licence exams. You can find more information on when you need a marine radio licence and who needs one on our website at truenorthmarine.com.au. Today's short video is an introduction to radar. The video will cover some terminology such as EBL, electronic bearing lines, or VRM, variable range marker. Now if these terms are new to you, then it's a good idea to pay particular attention to them because they are two very important functions on a radar unit. You could also Google those terms as well, and that would provide you with a lot more information, but it is important to make sure that you understand what they mean and how they can be used. They are essential navigation components of a radar, especially for collision avoidance. You should pay particular attention to such functions as using range and range rings, understanding the difference between head up and north up. Pay attention to what is the heading marker, and also there'll be some mention of relative bearings. So you need to make sure you're familiar with all of these terms while watching the video. It's probably one of those videos where you may need to watch it 2 or 3 times. And while some radars these days will have automatic clutter reduction, you should listen to what radar clutter is and how it is reduced. Okay, let's get started.
Radar, radio detection and ranging. It's not for this program to teach the subject, but to give you the basics of the system, which has probably done more to facilitate safe navigation than any other development. Radar works by extremely high-frequency radar waves transmitted from an antenna reflecting back from any object in their path, provided always that the object is capable of reflection. Wooden vessels, for instance, are not. If you are in a wooden or fiberglass vessel, always remember that in most cases you can't be seen by a ship's radar. In perfect conditions, some of your rigging may return an echo. Radar reflectors are extremely efficient these days. Don't leave home without one. The returned echo is displayed on the PPI, or Planned Position Indicator. It's shown as a beam of light rotating at the same speed as the antenna, highlighting any reflection. The center of the rotation beam represents the position of the radar set. On board a vessel, this can be used to plot the vessel's position relative to land, buoys, or other vessels, etc., which is arguably the system's most useful function. If another vessel is plotted at given intervals of time, that vessel's course and speed can be accurately ascertained together with advance notice of what's called the CPA, closest point of approach. Like GPS, radar can see through weather to a certain extent, although rain, etc. will give return echoes, called clutter. Each wave will also give an echo, so the idea is to set the gain high enough to reproduce echoes, but low enough to ignore rain and sea clutter. One of the most likely traps for the unwary is that of buying a radar set with a 48-mile range. Great. But radar, like the human eye, has limited over-the-horizon visibility. So for your radar to see that 48 miles, the antenna would need to be mounted over 1,000 feet high. Refraction will, to some extent, bend the radio waves to match the Earth's surface, but you can't expect an antenna that's mounted 15 feet above the water to see any more than about 5 miles. Here's a table of radar ranges. These are very approximate and based on perfect weather conditions. So, whereas the skipper of a 30-foot yacht with radar antenna mounted 18 feet high will have an horizon of around 5 miles, you have to add to that the height of the target. A cliff 500 feet high may be seen for up to 32 miles away, 5 miles for the antenna height, plus 27 miles for the cliff height. So it's a compromise. Position fixing is simple and very accurate. The beam of light will give the bearing of the object, and range rings superimposed on the screen will give the distance to the object. Collision avoidance. A skipper gets an echo at 4 miles distant, bearing 090. 5 minutes later, it reads 3 miles at 085. A third reading, 5 minutes later, shows 2 miles at 080. From those 3 readings, we can work out the course and speed of the target vessel, the time the vessel will cross our course and where, ahead or astern, and what distance the CPA will be. In this case, the target will pass ahead at a distance of just over 1 mile, and at its closest point of approach, approximately 18 minutes after the first contact, it will bear 020. You can also see that the vessel took 10 minutes to cross 2 miles of range rings, therefore her speed will be around 12 knots. Remember, displays can be set to head up, with the ship's course at the top of the screen. This relies on the radar set being connected to the ship's compass, or north up. This displays true north at the top of the screen. Bearings are then relative to the ship's course. When 2 vessels are seen to be on a collision course, it's what's called a close quarter situation, one where a vessel's skipper must take appropriate action. Radar can give you excellent warning of this. When a contact is first obtained, set the EBL on that bearing and watch the sweep. If later contacts stay on that same bearing, you're on a collision course. You can even work out how long you've got before collision occurs. It's the same as the visual situation. When you first sight another vessel, line it up with part of your vessel or rigging. If the other vessel appears to stay in that same relative position, you're on a collision course.
Well, that's it for our video today on basic radar operation and functions. See you in the next video.